All right, good morning, class. I just wanted to introduce a new part of the unit that we've been working on, the moon. We are now going to be moving into learning about eclipses. So, working towards the standard of the relative patterns of motion and positions of the Earth, moon, and sun cause solar and lunar eclipses, tides, phases. Specifically, right now, we're going to be working on just solar and lunar eclipses, both drawing them and explaining how they occur. So the two types of eclipses, like stated a few seconds ago, are solar and lunar. It's important that you know how words are derived in science. A lot of them have Latin and Greek root words. Eclipse means block, and luna means moon. Sol means sun. So when we're talking about a lunar eclipse, we're talking about a time when the moon is blocked from our view. So I kind of think about it as the moon is blocked. For solar eclipse, it would be the sun is blocked from our view to kind of help us remember what's being blocked, which will then help us figure out what is doing the blocking. So we talked in our last set of notes about how the moon revolves around Earth in a tilted orbit. So here in this diagram, you can see that the Earth is moving around the sun, and in four main positions of the Earth, you see the moon going around Earth in a tilted orbit. And the orbit stays the same throughout Earth's travel around the sun. So if you think about it and look at the words on this diagram, it says here the moon is too high for an eclipse. So here when the moon and the Earth and the sun, when the Earth's in this position around the sun, there is no eclipse. Because when the moon's on this side of Earth, it's going to be lower in its orbit, so there will be no blocking of anything. And then obviously over here you can tell when it's on this side of its orbit, it's higher up, and therefore there's no blocking of the moon's view. Now when we come to these two particular spots on the diagram, we see that even though the tilt remains the same, things start to line up perfectly. So and that's when we have an eclipse happen. We have the sun, earth, and moon where everything happens to line up on that same plane. So more specifically, the blocking or the eclipse of either the sun or the moon is due to a shadow. So when we say that an eclipse is occurring, it is the only time where there is a shadow involved in what we see in space. As far as last set of notes, we were talking about moon phases. It's a huge misconception that moon phases are caused by the shadow of Earth. So I don't want you to get confused when we start talking about eclipses. The only time that Earth's shadow falls on the moon is during the lunar eclipse. And the only time that the moon shadow falls on Earth is during a solar eclipse. So how does this happen? Well, the diagram up here does a great job of explaining it, and I have just gone through it. But it does have to do with tilted moon's orbit, and occasionally as the Earth moves around the sun, the lineup of the sun, the Earth, and the moon, or the sun, the moon, and the Earth is just perfect enough to create a shadow. Here is a diagram of a solar eclipse. During a solar eclipse, we know that the sun is blocked from our view. And so therefore, the moon is the object doing the blocking. So as you can tell, behind this moon, the sun is shining this way. We have the lit up side of the moon. We have the dark side of the moon. But behind the moon, we have this dark shadow. And that is because the moon is a rock. So therefore, if behind every solid piece of matter, there's going to be a shadow. So there is a dark, deep shadow behind the moon. And this part of the shadow is called the umbra, which we'll talk about. Okay, and then there is another shadow that forms during an eclipse, and it is a lighter shadow. So if you were anywhere where this lighter shadow falls that's created by the moon, then you will see a partial blocking of the sun, called a partial solar eclipse. Now, solar eclipses can only happen when the moon is in the position where we normally would see a new moon phase. So that means that the moon would have to be perfectly lined up in the center of the sun and the earth. Here's a diagram of a lunar eclipse. You can see here that now the moon has switched positions, gone about halfway around its revolution, where it falls perfectly in line behind the Earth. So here now the Earth is the object doing the blocking. We know that during a lunar eclipse, the moon is blocked. So again, what's doing the blocking? The Earth. Behind the Earth is a large shadow, and it is dark, and it's the umbra. Also, the other shadow, the penumbra, is a lighter shadow where it's only a partial shadow, and that is the penumbra. So, a little bit more details about umbra and penumbra shadows. Both are formed during an eclipse. The smaller part of the shadow is usually the umbra. The darkest part of the shadow is always the umbra. The umbra shape is also cone-shaped. Now, if you are located where the umbra shadow falls on Earth due to the moon, or where the umbra shadow falls on the moon, if you are in a location on Earth that can do that, then you are able to see no part of the sun or no part of the moon from your location. However, other people on Earth may be in what's called the penumbra shadow. This is usually the larger part of the shadow, and it is always the lighter part of the shadow. So, when you are located on Earth where the penumbra shadow falls on you, then you would be able to then see part of the sun during a solar eclipse or part of the moon during a lunar eclipse. Now, as you guys are aware, we had a lunar eclipse about 2.5 weeks ago, and we had a solar eclipse about half a week ago. This is just a picture that I took from the internet that shows what the solar eclipse looked like. And so you can see the moon shadow covering up the bottom part of our view of the sun. And the one before this that we could see was in April 8th of 2005. So we haven't really seen from Ohio, Cincinnati, many solar eclipses. The last one was about 9 years ago. So let's talk about total solar eclipses. It's important for you to know that the moon's umbra shadow is just long enough so that the point of that cone of the umbra shadow reaches the Earth's surface. And this is kind of an amazing thing because if the moon was a different size or a different distance from the Earth, this total solar eclipse would not happen. The moon would not be able to completely cover up all of our view of the sun. And we're going to go more in depth in just a second. It's a pretty cool thing that happens. Few people on Earth actually get to see a solar eclipse during their lifetime, a total one, and we just saw a partial one. However, I will tell you that later in class you're going to be doing some research about the next total and solar lunar eclipse and will we be able to see them. There is a solar eclipse in the somewhat near future that will be a solar eclipse for the Cincinnati area. And so you might want to look that up and see when it's going to be. But most people do get to see a partial solar eclipse just like we saw last week. So here's how this amazing event happened, where it's just kind of happened randomly that we are able to cover up, not we, the moon is able to cover up our complete view of the sun occasionally. So the sun's diameter is 400 times that of the moon. So how can the moon block out the sun? Think about it, 400 times in diameter. So how does the moon block our view of the sun? Well, the sun is also 400 times farther away from Earth. So not only is it 400 times bigger, it's also 400 times further. Think about it when you're viewing something that's off in a distance, how the size looks to you from a distance versus the actual size of that object. So what I'm trying to get you to think about is because the sun is so far away from us, it looks much smaller in our sky. And in fact, the moon and the sun actually look about the same size in our sky, even though they are far from the same size. So the sun and a moon appear to be the same size if they line up perfectly, which happens occasionally on a solar eclipse. This is what you get. The moon being the dark black spot and the rays background coming from the sun. Complete covering up of the sun by the moon. Total solar eclipse. So, now it's your turn to use this link, once the notes are done, to go back and find out when the next solar eclipse will be and when the next lunar eclipse. Look for total solar and lunar eclipses. And when will Ohio be able to see a total solar and lunar eclipse? Total solar and lunar eclipse.